Now, if you're looking at this, if you just watch the one about the ellipse, you're looking at the equations thinking, hey, aren't the equations basically the same thing? Well, that's a good and bad thing. Number one, they're not exactly the same. Number two, they're almost the same thing. And that's bad because you can easily mix them up. And you can pull out your formula sheet. If you haven't downloaded the formula sheet, please make sure to go back and to download the formula sheet. That's located on the very first conic section video. If you go down and just scroll down below the video, right below the notes, you should see the formula sheet download, or the link. If you look at these equations, what we see here is we have x minus h squared and y minus k squared. That's the same thing. A squared, same thing. B squared, same thing. But what's different? You have a negative sign. Now this one gets a lot different. Not only is it a negative sign, we now have the y squared term in front. If you remember with the ellipse, what changed was the location of A and B. Well, this time I have a negative sign. I really don't want to have a negative out in front. So what we've done is just simply swapped the values out, and rather than keeping the x in front, we're going to put the positive one out front. And so this happens to be where the y squared is. Now, how do you know which is which? Notice before, the a is going to always be larger. If the x squared term is out front, then you're going to have a horizontal transverse axis. Okay, it runs just like the x-axis does. If you're looking at where y squared term is out front, then you're going to be looking at a vertical transverse axis. Okay, the example we have today is using a horizontal transverse axis. Basically, that means that your hyperbolas are going to open up left and right. If you had a vertical transverse, they would open up and down. Okay, be very careful. I want you to really look at the equations for the hyperbola and the equation for the ellipse side by side so you can see the differences and you can know which one's which. Okay, just like in the other examples, what we're going to do is we're going to take an equation like this and we're going to put it into its standard form. Okay, in the last video, we talked about how to identify just the shape or the type of graph it is by looking at the coefficients in the equation we have to begin with. I automatically can jump to the hyperbola in this one because I noticed that my x and my y values are different signs. Automatically, that tells me that I'm going to have a hyperbola. Okay, step one, we're going to separate our terms. We have the x's, we have the y's, and the constant value. Notice the diagram to the side. You can see the hyperbola is a lot different than what we've looked at in the past. It's actually fairly complicated in terms of what it looks like. Once you understand all the parts of it, it's not that big a deal. Just to kind of connect what we've talked about before to what we're talking about now, we still have A, B, and C. And so A is the distance from the center to the vertex. B is the distance from the center to, we don't really call these the covertices. They're really not even any points at all, but how tall would that box be? And it's the same thing. You can call these the covertices if you want to. They don't really have a name, I don't think. But it would go from the center to the covertex here as well as the one at the bottom. C, here again, it's the same thing. It's the distance from the center to the foci, okay, or the focus. Notice that C in this particular one is larger than A. Last time, C was smaller than A. In a little bit, we're going to talk about the relationship between A, B, and C, and you'll notice that it has changed as well. The foci are always located on the transverse axis, and they are always inside the transverse axis, just like the parabola. Okay, let's go ahead and complete the square. We're going to remove the coefficients. We're going to factor them out. 4 comes out front, which makes my 32 drop to an 8, a negative 8. And this time, I have a negative 9 in front of my y squared, and I'm going to have to factor out that negative, so that's going to change the sign of this value. So negative 9 comes out. It leaves me with a negative 4. If you're curious, if you're not sure if you're doing that right, go ahead and distribute back and make sure that you get what you started with. Okay, I'm going to go ahead and take b over 2 and square that value, so half of negative 8 is negative 4 squared is 16. Half of negative 4 is negative 2. Squared is 4. I went ahead and made out the values at the bottom here. I went ahead and put the negative 4 and the negative 2 in. And now I'm going to go back up to this step and make sure that I add the correct numbers on the other side. 4 times 16 is 64. Negative 9 times 4 is negative 36. Be careful about your signs. If you miss the signs, then everything from that point on is going to be wrong. Right? Once you get to this step and you've combined your constant values, we're going to divide by that number. Divide by 36. Notice what I said earlier. If they swap, you notice you've got a good thing going. I divide the values. I notice they cancel out, and I'm left with a number like this. So that I can clearly see my center is at 4, 2. I can see that my A value is 3. My B value is 2. I notice that my X value is up front, so that means I'm going to have a transverse axis that runs just like the x-axis or horizontal. And you can see that in the picture. We have the transverse axis that runs like this. You have your conjugate axis that runs north to south. You can see the dotted lines or the screenshot from a calculator. You can see the hyperbola goes in like this. On the other side, it goes just around the other side. Here is C. We have that a squared plus b squared equals c squared. Here we go. We have the Pythagorean Theorem inside our problem for the hyperbola. So what we do is to find C. In order to find the asymptotes, the foci, I'm going to have C. So I went ahead and calculated that. And so the vertices, notice the vertices are all on the transverse axis, are all on the same horizontal line. So that you have a 2, a 2, a 2, a 2, and a 2, all for the foci, the vertices, and the center, just like we did when we did the ellipse. Okay, I did not write down the coordinates for what we would call the co-vertices. Those are really not necessary for this. The foci, in order to find them, I'm going to be adding and subtracting the C value to my X coordinate of my center, so changing the X value here. So I add and subtract the square root of 13 to 4, which would be here. I went ahead and put the approximation 7.6, 2 and 0.4, 2. Asymptotes. Now, if you're wondering, where is he getting all this information? Where is the formula? If you haven't downloaded the formula sheet, I might be making some jumps here that you don't really understand. Okay, make sure to go grab that formula sheet and have it with you while you're watching this. If you missed it the first time, go download it and then rewind this and watch it again. Okay, the formula for the asymptotes is quite easy. It has to do with your A, your B, your H, and your K. If you notice those, it's quite easy. Notice the two differences when you have the horizontal transverse or the vertical transverse. They're almost the same. It's just the switching of A and B. So you have 2, which is K, plus or minus. This would be B over A, X minus the H. So this is HK, and then this is just A and B. And so if you were going to write that out in individual values, you wouldn't write plus or minus. You'd write 2 plus and then 2 minus. Now, once again, as I said in the last couple of videos, make sure that if I were to give you only parts, let's say I gave you the center, or maybe I gave you the length of the transverse axis and the length of the conjugate axis. Now notice I've got lines drawing through them. Now I want you to make sure that the axes only go from the vertices to vertices, and then from the covertex to the covertex. So the length of it would be basically the length and width of the box that you see drawn here. So be careful. If I give you the parts, make sure if I gave you, let's say I gave you the major or the conjugate axis and the transverse axis, and I gave you the length of those, could you write out the equation that would go with that hyperbola? Okay, if I do know that, that allows me to find A and allows me to find B. It also allows me to find my center. From knowing A and B, because we know that A squared plus B squared equals C squared, I can find C. If you remember, the only thing I need to graph any of these is the center, my A, and my B. If I have those pieces, then graphing these or writing their equations, piece of cake. Just make sure that you know how they're all connected together.